So which topic we were discussing about, Kavya?
So just give me a minute, sir.
Okay.
The last class we were discussing about the Coulomb's law, sir. Then we read about the properties of electric charge, sir. Additive of charge, conservation of charge, quantization of charge, sir. And then Coulomb's law, sir. Then we read about the dimension of K, sir, and how we got the Coulomb's law, sir.
Did we do any numericals, Kavya, regarding
No, sir.
quantization of charge?
We did quantization of charge, we did numerical, sir.
Okay. So numerical we have done, yeah.
அது கலர் போயிடும் ஒரு மணி நேரம் போட்டுரும்.
Okay.
Yes, sir.
Okay. So what we have read about what is the unit of electrostatic constant, Kavya?
Sir, unit is nm square coulomb square, sir.
Newton meter square per coulomb square. This is the unit of electrostatic constant. And what is the value of electrostatic constant, Kavya?
Value, sir, for K, sir, 9 into 10 raised to 9, sir.
9 into 10 to the power 9. And the formula?
Formula is, sir, K equal to 1 by 4 pi epsilon 0, sir.
Good. What is the value of epsilon naught, Kavya?
Epsilon naught is 8.854 into 10 raised to negative 12, sir.
Good. I hope you have discussed. I hope you had read about it. Okay.
Yes, sir.
Okay.
And sir, epsilon naught value is unit is coulomb square nm square.
Okay.
Divided
Coulomb
by-
square per Newton meter
by
square.
Newton meter square, sir.
Okay. Because epsilon naught is the inversely proportional to electrostatic
So
constant.
epsilon naught equal to 1 by k, sir. So
Yeah.
using that we'll do the formula.
Yeah.
And sir,
I
we
hope-
learned about EM, sir, permeability of medium.
Yeah. It is the permittivity of epsilon m. This is the permittivity of medium. I hope you got to know about these all things. Yeah.
Yes, sir.
Okay. So let's do something new, some numericals regarding Coulomb's law, Kavya. Okay.
Yes, sir, sure.
Okay. So write the numericals. I'm saying, okay. The force of attraction
The force of attraction, sir.
between 4 microcoulomb
Between 4
microcoulomb
micro coulomb, sir,
and minus 10 microcoulomb
and minus 10 microcoulomb, sir.
Find the force of attraction between 4 microcoulomb and minus 10 microcoulomb separated by a distance 10 centimeter. Okay. Find the force of
Force of attraction of 4 microcoulomb to 10 microcoulomb.
minus 10 microcoulomb separated by a distance 10 centimeter.
Separated by a distance
10 centimeter.
10 centimeters. Okay, sir.
Find it, Kavya.
So, uh, using the formula K, Q1, no, we have to use charge formula, right, sir?
We have to use Coulomb's law, Kavya. What is the formula of
That's what, sir. FR squared by Q1 into Q2, sir.
Q1 Q2 by 4 pi epsilon naught r square. This is the formula of Coulomb's law, Kavya. Okay.
R square, sir, R square is 10.
It is the distance 10 centimeter. You have to convert centimeter into meter, Kavya. Okay. And microcoulomb into coulomb.
Q2 is 4 and 10, sir.
Yeah. If you convert 4 microcoulomb into coulomb, you have to find you get 4 into 10 raised to power what? Minus 6
Sir, minus
coulomb. Okay.
I'll try to solve, sir.
Okay. You have to find the force. These all things are given.
Yes, sir. I'll do it, sir.
Okay.
So 4 into 10 raised to negative 6 into negative 10 into 10
Negative 10 no, Kavya, because Q1 Q2 in magnitude has a magnitude. Okay, so negative charge will be converted into positive. Okay,
Okay, sir.
so you don't have to take minus 10, you will take only, you have to take only plus 10.
So should I write pi value as 22 by 7 or 3.14, sir?
What?
Pi value should I take 3.14, sir?
We know the value of 1 by 4 pi epsilon or naught is 9 into 10 to the power 9. We know, yeah.
Sir.
So you have to take 1 by 4 pi epsilon naught 9 into 10 to the power 9.
Okay, sir.
Mm. Don't take value of pi 3.14. 1 by 4 pi epsilon naught, this is the direct value, Kavya.
Okay. So 4.10 raised to
4 point
no, sir. 4 into 10 raised to 3, sir.
4 into 10 raised to 3. Newton. This is wrong, Kavya. Let me confirm you. Okay. So we have to find the force. Okay. The formula of
Uh,
force is
Sir, better can I send my working?
what?
Can I send my working in the group, sir? Better.
You can send in my group, in our group, Kavya.
Oh, okay, sir.
Okay. So let me confirm you. Okay.
Okay.
Okay. So what is the formula of force, Kavya? Q1 Q2 by 4 pi epsilon naught r square. This is the formula of force. Yeah.
Sir.
Okay. So we know the Q1 Q2 is in the modulus form, so that the negative value will be converted into positive. Okay. So
Sir.
here Q1 is equal to 4 microcoulomb and Q2 is equal to 10 microcoulomb. Okay. So if we convert the microcoulomb into coulomb, what will be 4 into 10 to the raised to power minus 6 coulomb, and here will be 10 into 10 raised to power minus 6 coulomb. Okay.
Yes,
Understood,
sir.
Kavya?
True.
Okay.
Ah,
So put this value in these charges. So here 4 raised to 10 raised to power minus 6 into the value of Q2 will be 10 into 10 raised to power minus 6. And what is the value of 1 by 4 pi epsilon naught, Kavya? 9 into 10 to the
9
power
into
9.
10 raised to 9, sir.
Okay.
So 0 point, sir said I have to convert 10 centimeter into meter, sir. It will be 0 0.1, sir, square.
10, if you convert 10 centimeter into meter, then you have to divide with 100. Yeah.
Sir.
Okay. So we will convert, Kavya. Let's take first the value of 1 by 4 pi epsilon naught. What is the value of 4 pi epsilon naught? 9 into 10 raised to power 9. Okay. Divided by r square. R square means 10 by 100 whole square. Okay.
Sir.
Understood? So
Yes, sir.
if we cut 0 0, okay, and here the basis will be 10 raised to power minus 6, 10 raised to power minus 6, 10 raised to power 9. Okay. And here will be 10 raised to power 1. Okay. So multiply 9 into 4, Kavya, first. Okay. This is 9 and this is 4. What is 9 4s are 36?
Sir.
Okay. And here 10 raised to power minus 6, 10 raised to power minus 6 will be 10 raised to power minus 12. Okay.
Yes, sir.
And here 10 raised to power 1 and 10 raised to power 9 will be 10 raised to power 10. Okay.
Yes, sir.
And we have here 1. Well, 1, if we is squaring 1, we will get 1, and here we will have 10. The square of 10 will be 100. Okay.
Yes, sir. Yes, sir.
Here 1 by 100, and this 100 goes to numerator. Okay. Understood, Kavya? So
Yes, sir. Understood.
what we will get? 36 into 10 raised to power minus 12, 10 raised to power 10, and we can write 100 into 10 raised to power 2. Okay. Can we write 10 raised to 100 into 10 raised to power 2?
Yes, sir. We can
Okay.
write.
So we got the value 36 into 10 raised to power minus 12 into bases are same. So we can write here 10 raised to power 12, Kavya. Understood, Kavya?
Yes. Yes, sir.
So this 10 raised to power minus 12 and 10 raised to power 12 are cancelled out, and we got 36 Newton force. Okay.
Okay, sir.
Okay. Write it, Kavya.
Sir, can you check my workout, sir? In the group.
Okay, let me check. 9 into 10 raised to power 9 is not in you put in denominator kavya. Okay, you have to put it into numerator. Okay, because the value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Okay,
Yes, sir.
so here will be 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught, the value of 1 by 4 pi epsilon naught will be 9 into 10 to the power 9. Okay, so you have to put it into numerator kavya, not denominator. Okay,
Yes, sir.
so 1 by 4 pi epsilon naught value you have to put into denominator, not numerator. Okay,
Yes.
okay, so this is your wrong. Okay, you have to put it into numerator,
Yes, sir.
or you put it into denominator. This will make your answer wrong.
Yes, understood, sir. Done, sir.
Okay, so let's do one more question, Kavya. Okay,
Okay.
so right, find the force of attraction. Find the force
Yes,
of
sir.
attraction between 2 microcoulomb and 12 microcoulomb separated by a distance, separated by a distance 10 centimeter. I hope you will make this correct. Okay,
Yes, sir.
all question are same but value are changes.
Okay, sir. I'll do it
Okay.
right, sir. Sir, while doing the exponential form, sir,
Hmm.
uh,
What
sir,
you
it
will
is,
get?
sir, 24 into 9 into 10 raised to negative 12 plus 9, sir. Is it
10
correct, sir?
raised to negative 12.
plus 9, sir.
Plus 9.
No, sir, in the top, the exponent, sir.
Plus 9. So minus plus minus, you will get 24 into 10 raised to power minus 3.
Yes, sir.
Plus minus minus, if we subtract 12 to 9, we will get minus 3 because larger number is 12.
Yes, sir. So 24 into 10, sorry, sir. So 216 into 10 raised to negative 1, sir.
10 raised to negative 1. Good. If we 10 raised to negative 1, if we um, take negative
We
1, we
don't.
can 2.21.6 Newton. Yeah, this will your answer. If this negative 1 goes to denominator, it will be like this 10. Okay, and we can write 21.6. Okay,
Yes, sir.
10 raised to 1. Okay, correct hai yahan pe. Got it?
Got it, sir. Yes, sir.
You want some more numericals? If
Sir, I can do it as a homework, sir. Sir, sir.
okay, okay. So let's discuss next topic. Okay.
Yes, sir.
Okay. So write Kavya Coulomb's law in vector notation. First, Kavya, write the limitation of Coulomb law. Okay.
Yes, sir.
Let know limitation of Coulomb law. Write the topic. Limitation of Coulomb law. Coulomb's law. Okay.
Yes, sir.
So first limitation is, right Kavya, charges should be in rest. Charges, because we are discussing about electrostatics, so we must take charges at rest. Okay.
Okay, sir.
Charges should be in rest. This is the first limitation. Second one is charges should be small, very small. Okay. Charges should be very small. Third point is separation between charges should not very large as well as small. Separation between two charges should not very large as well as small. Okay, we have
Yes,
to
sir.
take charges which is at rest, Kavya. This is the limitation of Coulomb's law. If you
Yes,
take
sir.
movable charges, Coulomb's law does not occur. Okay,
Okay,
will not
sir.
occur. So charges should be in rest. Charges should be very small. You have to take small charges when you apply the Coulomb's law. Okay.
Yes, sir.
And third point is separation between two charges. We suppose we are taking two charges Q1 and Q2. Okay. So you don't have to take much more distance between two charges. Okay.
Yes, sir.
So charges will be not very large or not very small. Okay. Suppose I am
Yes.
taking two charges like this. So there is no distance between them. So how can we apply Coulomb's law? We can't be able to apply Coulomb's law. Okay.
No, sir.
So charges between separation between two charges should not be very large and should not be very small also. Okay.
Small also, sir.
Hmm. This is the limitation of Coulomb's law. whenever we have to apply Coulomb's law, so we have to know these types of limitation. Okay.
Yes, sir.
So next, write it, Kavya.
Sir. 1 minute, sir. Yes, sir. Done, sir.
Okay. So the next topic will be Coulomb's law in vector form. Okay. Coulomb's law in vector form. So before discussing about Coulomb's law in vector form, we have to draw a coordinate which have one x-axis and another one is y-axis. Okay, and this is the origin point of the coordinate, Kavya. Suppose we are taking two charges over here, q1 and q2 charge. The distance between these two charges from origin is r1 and r2. Okay, this is straight line, Kavya. Okay,
Yes, sir.
the distance between q1 from the origin is r1 and the distance q2 from the origin is r2. Okay, so here we are taking two positive charge, Kavya, plus q1 plus q2. Okay, so what we see here, that this q1 charge repel this q2 charge. Okay,
Yes, sir.
this q, the big and distance. Okay, this is the distance between it, these charges. What we see here, that this q1 charge repel this q2 charge over here. Okay,
Yes, sir.
this is the force on charge 2 due to charge 1, due to charge q1. Okay, you got to know how am I write this?
Yes, sir. Able to answer.
Force on 2, force on charge 2 due to charge 1.
1.
Okay, that's why I am writing F21. Okay, F21 shows us force on charge 2 due to charge 1. Okay,
Yes, sir.
okay, so q2 will also repel q1 this side, Kavya. Okay, so we can write here force on charge q1 due to charge 2.
Yes, sir.
Okay,
Sir.
and the distance between q1 and q2 is r, the distance between q1 and q2 is r12, this distance. Okay, when force on charge 2 due to charge 1, the distance between it is r12. Okay, Understood,
Yes, sir.
Kavya?
Sir.
Okay. And when charge q exert on charge force on charge 1, the distance between them is r21. Okay, 2 to 1. 2 to 1 means force on charge q1 due to charge q2. The distance between them is r21, and f21 distance will be r21. Okay, understood, Kavya?
Sir. Understood.
So here we can see that both r12 and r21 have same difference but opposite in direction. Okay, so
Yes,
can
sir.
I write this r12 is equal to minus r21 because both have direction opposite? Can I write this, Kavya?
Yes, sir.
R12 is equal to minus r21 because r12 goes this side and r21 goes this side. Okay, understood,
Yes,
Kavya?
sir.
because of
Understood.
because of opposite direction, I can write r12 is equal to minus r21. Okay, so
Yes, sir.
now we have to find the force 21. Okay, so f21 according to Coulomb's law, what is the force f21, Kavya? What is the formula of Coulomb's law?
Sir, K equal
K
to
q1 q2 by r
Q2
square. Yeah,
R square. Yes.
it means k q1 will be here, q1, and q2 here, q2 by r square. What is the distance between q1 and q2, Kavya? F, I am finding f21. So f21
Q1.
distance will be r12.
R2, sir.
R12
R1.
R12 is the distance of f21. Okay,
Yes, sir.
okay, so here I can write r12 का square. Okay,
Yes,
and
sir.
here I am writing vector form, so I have to take one unit vector which is r12. Okay, this is the unit vector which value is 1. Understood?
Yes, sir.
Because I am taking in vector form, so I have to take magnitude as well as direction also, and this unit vector shows the direction of f21 this side. Understood?
Yes, sir.
This is the value, Kavya. This is the this unit vector has a value 1. I am writing because here is a vector form. Okay, so I will
Yes,
take
sir.
this equation 1. Okay, and find f12, Kavya. So what is f12, Kavya? K q1 q2 by what is the distance f for f12, Kavya?
Sir,
R21.
R21, sir.
Okay, R21 is the distance of f12 and R12 is the distance of f21. Okay,
Yes, sir.
so the distance of f12 will be R21 square. Okay, into
Yes, sir.
R21 unit vector. Understood, Kavya?
Sir.
Why I am taking unit vector? Because this is in vector form, so I have to take magnitude as well as direction also. Okay,
Yes, sir.
so this is the equation 2, Kavya. So if I relate from equation 1 and 2, what we see here, I am writing also r12 is equal to minus r21, Kavya. Can you see?
Yes, sir.
So r12 is equal to minus r21. I will take this equation 3, Kavya. Okay, so if I put this value r12 is equal to minus r21 in equation first, put the value of 3 in equation first, Kavya.
Okay.
What will we get? So putting the value of 3 in first.
One, sir.
Okay, so what we will get here, I can write r minus r21 in place of r12. Here R12 will be converted into R minus R21.
R minus
Minus R21. I can write minus R21 in place of R12. Can I write, Kavya?
1. Yes, sir.
Okay. So here I am writing F21. F21 is equal to K Q1 Q2 divided by R12 square, which means minus R21. I can write minus R21 in place of R12. Kavya, understood?
Yes, sir.
Okay. So here I am writing R minus R21 in place of R12. Okay. So minus R21 square, whole square. Okay. Into this will also R12. So I am writing R21 minus unit vector. Understood, Kavya?
Yes, sir.
Okay. So here I am writing also. So minus R21 square will be plus R21 because it is in square form, Kavya.
Yes, sir.
Okay. So here we can write F21 is equal to KQ1 Q2 by R21 square into minus R21 unit vector. Understood, Kavya?
Yes, sir.
So can you see, Kavya, F12 and F21, all the values are same,
Yes, sir. Same.
but the direction R21 will be here minus R21. Are you seeing here?
Yes, sir. Sir.
Yeah. So we can write here F12 is equal to minus F21. This is the Coulomb's law of vector notation, Kavya. Understood? Why I am writing here minus F21? Because here is minus R12 or here is R21 only, and here is minus R21. So this shows the opposite direction. Here we can also see that the direction of R12 is here and R21 is here. Okay. R12 goes this direction, R12 is going this direction, and R21 is going this direction. Okay. This direction shows the negative force. So we can write forces are equal in magnitude but opposite in direction, Kavya. We can write here.
Yes, sir.
Understood, Kavya?
Yes, sir. Yes, sir. Understood, sir. Yeah.
Okay. So we can write here forces are equal in magnitude. Equal in magnitude. Magnitude but opposite in what, Kavya? Opposite in
Opposite in the other
direction. Opposite in
direction.
direction. F12 is equal to minus F21, which means these both forces are equal in magnitude but direction is opposite. You can see here F21 goes this direction, F21 goes this direction, and F12 goes this direction. Is going this direction. Okay.
Yes, sir.
Direction. So forces are equal in magnitude but opposite in direction. This shows the Coulomb's law in vector form. Okay.
Yes, sir. Yes, sir.
Write it, Kavya. If you have any problem, you can ask me, Kavya.
Yes, sir. Sure. So no problems. I am able to understand it, sir.
Okay. Write this figure clearly, Kavya. Okay.
Sir.
डन काव्य. Hello.
Sir, just the figure, sir. 1 minute, sir.
Draw this figure clearly, Kavya. So where is going R12 and where is going R21? Okay.
Sir, can you draw this again in the next week, sir? Actually, it's
Okay, okay. I am
little bit.
drawing. I am drawing. Okay. This is the coordinate. Okay. This is x-axis and this is y-axis. I am taking two charges over here,
Yes, sir.
Q1 and Q2. Q1 charges is this, Q2 charges is this. The distance between two charges is, this is the origin point, Kavya. Okay.
Yes, sir.
And this, the distance between this is a straight line, Kavya. Okay. The
Sir.
distance between Q1 from the origin is R1 and Q2 from the origin is R2. Okay.
R2.
So here we can see that both forces are same, both charges are same, like charges. Okay. So
Yes.
this Q1 charge repel this Q2 in this direction. Okay, so we can write here force on 2, force on 2, charge 2 due to charge 1, F1, F21. Okay, and that distance between them is R1 to 2, R12. Okay, so
Yes,
F21
sir.
distance will be R12. Okay, done, Kavya? And
Yes, sir. Just give me.
Q2 Q2 also exert force on Q1 in this direction. So we can write force on charge 1, force on charge 1 due to charge 2. Okay,
Yes,
force
sir.
on charge 1 due to charge 2, and the distance between them is R2 exerting on 1, charge 2 exerting force on charge 1. So I can write here R21. So this R21 distance lies to F12,
Yes.
and this R12 distance lies to F21. Okay,
Yes, sir.
that's why when I find F21, I take R12 distance. Okay.
Yes, sir.
Understood this figure, Kavya?
Understood, sir. Yeah.
Okay.
Yes, sir.
Write this figure from scale, Kavya. Okay.
Yes, sir. Yes, sir. Done, sir.
Okay. So let's discuss the next topic, dielectric constant.
Yes, sir.
Dielectric constant. We can also write it as relative permittivity. Relative permittivity. Okay, write the definition of dielectric constant or relative permittivity Kavya. Dielectric constant is symbolized as K Kavya, okay?
Yes, sir.
And relative permittivity is symbolized as epsilon R. Both are same, okay?
Yes, sir.
So, the definition of dielectric constant is it is the ratio of it is the ratio of absolute permittivity of medium, absolute permittivity of medium to the absolute permittivity of medium to the absolute permittivity of free space, of free space. Okay, it is a ratio of absolute permittivity of medium to the absolute permittivity of free space. Okay, this is dielectric constant Kavya. You can write it here Kavya, also write it here, absolute permittivity of free space. Okay,
Yes, sir.
free space to the absolute permittivity of medium. You can also write it medium. It is the ratio of absolute permittivity of free space to the free space. Wait. What is doing here? Free space. What is going on here? Write it Kavya, I'm saying, okay? I think there is some technical problem. What you have write Ravya? It is the ratio of absolute permittivity of free space to the absolute permittivity of medium. Okay?
It is a ratio of, sir.
It is the ratio of absolute permittivity of free space.
Absolute permittivity of
Free
free
space
space.
to the absolute
To the
permittivity of medium.
okay, sir. Done, sir.
Okay.
Sir.
Absolute. You can also write absolute permittivity of medium to the absolute permittivity of free space. You can also write it. Okay.
Yes, sir.
Okay. So it is the ratio of absolute permittivity of medium to the absolute permittivity of free space. So for dielectric constant, if I am taking for vacuum, okay, free space will it means vacuum. Okay, there is no one between two charges q1 and q2. Suppose we have two charges q1 and q2. There is no one between them. Okay, Kavya. Okay. So for vacuum, for vacuum, force, I can symbolize it as F naught. Okay. The force will be Q1 Q2 by 4 pi epsilon naught r square. Okay, this is according to Coulomb's law. What is the formula of force Coulomb's law according to Coulomb's law, Kavya? F naught is equal to
F naught equal to Q1 Q2 4 pi epsilon naught
not r square. So I am taking it equation first. Okay, and for medium I am taking force as Fm, force on medium. Okay, Fm will be force on medium. Okay, so here will be Q1 Q2 by 4 pi epsilon m r square Kavya. Okay, read it Kavya, got it?
Yes, sir.
Here is the medium, that's why I am taking epsilon m. Okay, I am taking this equation 2. So dividing equation 1, what we will get? Dividing equation 1 from equation 2. If I divide equation 1, what is equation 1 Kavya? F naught divided by Fm. Understood Kavya? I am dividing equation 1 from equation 2. So F naught divided by Fm. Understood Kavya? I am audible Kavya?
Yes, yes, sir. Is audible.
Okay. Dividing equation 1 from equation 2. So what we will get? What is the formula of F naught? Q1 Q2 by 4 pi epsilon naught r square. Understood Kavya?
Sir.
Okay. And the formula of Fm will be Q1 Q2 by 4 pi epsilon m r square. Understood?
Sir.
These two charges are cancelled out. 4 pi epsilon naught are also 4 pi epsilon naught not. Okay, wait. 4 pi and 4 pi are cancelled out, and r square are cancelled out. Okay,
Sir.
so what we will get? F naught by Fm is equal to 1 by epsilon naught divided by 1 by epsilon m. Understood Kavya?
Yes, sir.
Okay, epsilon m. So I can write it also, F naught by Fm is equal to epsilon m by epsilon naught. Understood Kavya?
Yes, sir.
And epsilon m. And what I am writing here in dielectric constant, what is the definition of dielectric constant, Kavya? It is the ratio of absolute permittivity of medium to the absolute permittivity of free space. Okay, here epsilon m is the absolute permittivity of medium, and epsilon naught is the absolute permittivity of free space Kavya. Understood?
Yes, sir.
So this is dielectric constant K as well as epsilon R, relative permittivity. Okay Kavya?
Sir.
You know how I am cut it Kavya?
Yes, sir. Sir.
Okay.
Yes, sir. Answer completed.
Is there any problem Kavya?
No, sir. No problem. Understood, sir.
Okay. So here the dielectric constant, the formula will, what is the definition of dielectric constant? It is the ratio of absolute permittivity of medium to the absolute permittivity of free space. Okay.
Yes, sir.
Okay. We can also write it is the force between absolute permittivity of, it is the ratio of forces of absolute permittivity of free space to the forces of absolute permittivity of medium. We can also write it Kavya. Okay. These both are the definition of dielectric constant. Forces of permittivity of free space to the forces of permittivity of medium. This is the ratio of forces of vacuum to the forces of medium.
Yes, sir.
These both are the, we can write the definition. Okay. So here we can see, Kavya, that F naught by Fm belongs to dielectric constant K. Okay.
Oh, yes, sir.
So
Yeah.
I can write it also, F naught by Fm is equal to K. Okay. Because this is dielectric constant and dielectric constant is symbolized as K. Okay. Hello.
Yes, sir. I'm there, sir.
Okay. So the formula will be, if I find the forces in medium, so forces of medium will be F naught by K is equal to Fm. Okay. This is the formula of forces of medium, Kavya.
Yes, sir. Sorry, sir. I was on mute. Yes, sir. Understood, sir.
Okay. So let's keep this topic for today, Kavya.
Yes, sir.
Okay.
Sure.
What you are facing? You are facing any problem for schedule, Kavya?
Sir. Actually, there's a mix of bio classes and other practice classes, sir. So that's why.
So
Anyways, sir, I'll let you know, sir. But
are
that
you
only.
are you comfortable in 9:15, Kavya?
So
In
sometime
Tuesday, Thursday, and Saturday?
9:15 in Tuesday, Thursday, and Saturday, sir. See,
Are,
Saturday I can't attend 9:15, sir.
so
That
Saturday,
I
but
can't
Tuesday and
attend.
Thursday, are you comfortable in 9:15?
Tuesday, Thursday is fine, sir.
Okay.
Yeah.
So in Saturday, when will you attend the class?
I can attend 4 to 5, sir.
Acha. In evening.
Yes, sir. 4 to 5.
Okay. So these all are, this all you got to know all these things, Kavya?
Sir. 4 to 5. Yes,
Oh,
sir. Understood, sir.
okay. Okay, Kavya.
Yes, sir. Thank you, sir.
Okay.
Good night.
Good night.